All right, let's take a look at finding the line of best fit, also known as linear regression. So I have a set of data here. Um, it's dealing with the age of a car, the price, the value of a car. So let's see, copy this data over. And it's basically a table that you'd have been given on the test, similar values. So these are the x values, these are the y values, the x squareds, the y's squared, and the x times y's. And at the bottom we have the sum of each of those. So part of it's done for us already. So remember that to get the slope, we need the sum of the squares of xy over the sum of the squares of x. So then, well, what was the sum of the squares of xy and sum of the squares of x? Sum of the squares of xy, that's the sum of the x times y column. So this is where we took the x times y, x times y. So this is the column from doing each x times its corresponding y, and this is that sum. This is what we got when we multiplied x times y and then added each of those values up. And we're going to subtract the sum of the x's, so this is the sum of the x's, times the sum of the y's, this is the sum of the y's, over the number of data points. So when we refer to a data point, we mean an ordered pair. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ordered pairs. So 10 data points. So our sum of the squares of xy is 830.5 minus the product of 45 times 203.4 over 10. So pull the calculator out. Order of operation, we need to multiply this numerator and then divide by 10. So 45 times 203.4 divided by 10. So 915.3. So 830.5 minus 915.3. So for the sum of the squares of xy, we've got 830 minus 915.3, which is negative 85.3. Negative 85.3. Now if we can get the sum of the squares of x, we can combine that and get the slope. So for the sum of the, recall that that's the sum of the x squared column, meaning we square x, then we add those up. So this is what we get when we squared the x. 25 is 5 squared, 9 is 3 squared, 4 squared. So this is the x squareds, and then we add those up. Then we subtract the sum of the x's, which means what do we get when we add up the x values? That number gets squared divided by the number of data points. So when we square our x's and then add those up, we get 233. When we add up our x's, that's 45. And then we're supposed to square that. So whatever the sum of x is, square that and divide by 10. So 233 minus 45 squared divided by 10 202.5 so 233 minus 202.5 gives us 30.5. So if we want our slope, which in the book they use Y notation instead of M in B notation. Generally in math we use M for the slope, so for our slope, it's the sum of the squares of xy over the sum of the squares of x. So negative 85.3 divided by 30.5. So negative 2.7967. So to 3 decimal places, negative 2.797. Negative 2.797. So that's what we get for our slope. Now to get our y-intercept, again, the book uses y notation, but in math, normally we say a line is y equals mx plus b, where m is the slope, b is the y-intercept. So we'll call it b. The y-intercept is the sum of the y's minus the slope times the sum of the x's divided by the number of data points. When we added up our y's, not to be confused with the sum of the squares of y, but when we just add up our y values, we get 202.3 minus our slope, negative 2.797, times the sum of the x's, so not the sum of the squares of x's, but just this means add up the x values. This means do this whole formula. So if we're just adding up our x's, when we add our x's, we get 45. And then that's divided by the number of data points, 10. So in parentheses, if we multiply our slope, negative 2.797 times 45, we get negative 125.865. So it's minus that, so minus the negative, that'll make that a positive, over 10. So 203.4 plus that number we just got, and that divided by 10, 32.93. So now that we have our slope and our y-intercept, our equation of our line is y equals our slope times x plus our y-intercept. So that's the equation of our line of best fit. Now if we were wanting to plot that line, we would need 2 points to plot a line. 1 point is the y-intercept. If we were to put a 0 in for x, if you let x be 0, if we replace x with 0, anything times 0 is 0, so we would get 32.93. Hence, that's the y-intercept, that's on the y-axis. If we need another point so that we can connect the dots, graph our line, just pick another value for x. We had x's that went up to 7, so let's pick 6. Doesn't really matter. We can, just as long as we don't go too far past our upper value. So if we put a 6 in, take our slope times 6 plus 32.93, 16.148. So if we had a grid, we could plot both of those points, draw a line through them, and that would be a graph of our line of best fit. Now another thing we were asked to do is to take our equation and predict what the value of the car would be at a certain time. So if X stands for the age of the car, if we want to know the value of the car when it's 8 years old, we want to predict the value of the car when it's 8 years old. That's the X value. So we replace X with 8. So we do our slope times 8. So negative 2.797 times 8. And then add our y-intercept. We get 10.554. Now we need to interpret what does that mean. That doesn't mean that the car is worth $10.55. That's the price in thousands. So this is how many thousands. So we can take that and multiply it times 1,000. Get $10,554. So that would be the value of the car when it's 8 years old. So this is just going to get an overview of how do we find the line of best fit? How do we manipulate the formulas? One of the biggest areas people get confused on is, when do I use the sum of the squares of x? When do I use this? So SS of x, that means the sum of the squares of x, which is this whole formula. Sigma x, that's just add up the x values. So that's just 2 plus 5 plus 3 plus 4 on down. So just be sure you know the difference between those two, and also the difference between the sum of the squares of xy and the sum of the xy's. This means multiply x times y. We multiplied each x times this y, and this sigma means add all those up. So this is what we get when we add up the product of x times y. This means this whole formula. So earlier I circled this for the sum of the squares of x. Actually, this was the sum of the squares of x. This was the sum of the squares of xy. So don't get this one and that one confused. The sum of the squares of x, that's all of this. The sum of the x's squared, or the sum of the x's, that's just add up the x's. This one is just square the x's and then add all those up. So also don't get those confused.